Good morning. It is 9 o'clock here in California. I am Francis Savignan, the founder and CEO of EPARTRADE. With me this morning, we've got Judy Keane, the co-founder, and Brad Gilley, our special host. Good morning, Judy. Good morning, Brad.
Good morning.
How are you guys doing today?
Doing good. Looking forward to the next hour for sure.
Exactly. So this is episode 98 of the EPARTRADE technical and webinar series. And we're very excited to have Reid Rocker Arms with us, Judy, right?
Yep. It's going to be a fantastic, Daryl just knows everything about Rocker Arms, and Joe is a great companion testimonial on this next hour.
Thank you. And they have been a long time supporter of the EPARTRADE platform. So thank you very much, Daryl. Anything you want to add about the platform, Judy?
Well, I just want to remind everybody that we have hundreds of suppliers on this platform, literally on here to connect with buyers all the time. So once you log in, if something sparks any interest, you just hit request more information. The lead goes through to the supplier and you guys do your business off the platform. We support connection.
Absolutely. Thank you very much. And I see that Daryl is coming on right now, and we're going to bring Joe as well. And so, Mr. Gilley, you're in charge for the next hour, and we're delighted to have you back. So thank you very much. Give me 1 second. I see Joe popping up. We want to make sure sound is working. Good morning, gentlemen. So Brad Gilley, you're in charge.
Well, thank you, Francis, and thank you, Judy. We really appreciate that. For the next hour, and this is going to be so much fun, the title of today's webinar, Rocker Arms for Race Engine Applications, What You Need to Know, presented by Reid Rocker Arms. And our two panelists today, Daryl Reid, the owner of Reid Rocker Arms, and Joe Bettencourt, the CEO and founder of Joe Bettencourt Motorsports. And here over the next hour, we're going to talk about Reid Rocker Arms and really everything they offer. It's not just Rocker Arms, complete valve train components, and answer any questions that you might have as well. If you do have a question for any of our panelists, then by all means, please type it into the chat, and we'll do everything we can to answer every possible question that you might have. And today's webinar, quite honestly, is probably going to get a little technical, and that's going to be great. I know a lot of people who are truly interested in this. It's the technical knowledge that you really need. And for someone like me who may not be quite as technical, we'll also try and explain everything that we can in layman's terms. But Daryl and I had a great opportunity earlier today to spend about 30 minutes on the phone, really just chatting about just the fascinating world of really what Rocker Arms and valve train components and all of that can do for your race engine application as well. So Daryl, I'll start with you, and then we'll talk to Joe. And as always, if either of you feel the need to add to something that one of you has said, always jump in. We definitely don't want to leave anything on the table or leave anything out here today. So Daryl, first of all, thank you, and tell us a little bit about Reid Rocker Arms.
Well, thank you for having us. And Reid Rocker Arms was started in 2005 as Reid Machine. We started out as a job shop, got involved in valve train in late 2006, and have been involved ever since. It's a continuously evolving project, and learning experience for me as well. I've spent 45 years in machining and manufacturing, so it lends itself well to the components that we're making.
Well, Joe Bettencourt, if you would just kind of give us an idea of exactly what you do and everything that happens at Joe Bettencourt Motorsports.
I'm a small engine builder in Central California. But I've done fairly well with some pro mod racing, some alcohol dragster racing over the years. And about 10 years ago, I opened my own business, Joe Bettencourt Motorsports, and I either build motors for people or consult and or go to the racetrack and tune for them.
Awesome. Well, Daryl, let's first talk about the race engine applications that we're going to be talking about here. Obviously, you do a lot when it comes to drag racing. I mean, it's beyond actually what happens on the asphalt, as you were telling me a little bit earlier. But what type of engine applications are we most talking about here?
The two main combinations are the 426 alcohol motors for blown alcohol for alcohol funny car, alcohol dragster, pro mod, boats, tractor pulling, and that pretty much covers that. We do also nitromethane, like the latest is the new assembly. I'm sorry, I'm spacing a little bit. The newest assembly for the nostalgia funny cars with the single magneto nitro burning engines. We just released that product this past weekend in Boise, and so things look promising there. So we cover the whole range of high performance, super performance engines, blown, injected, and both alcohol, nitro, and even some gasoline engines.
Well, Daryl, give us an idea of, look, there's been a lot of different suppliers that we've talked to here during our Race Industry Now or during Race Industry Week when it comes to engine internals and, from pistons to rings to crankshafts and cams and all of that. Rocker Arms specifically, and really the valve train components, because we know it's not just one piece that makes everything work. Getting into this side of it, getting into this part of the engine and really what people need to know and where your product might stand out.
Well, it's said that the heart of a healthy motor is the valve train, and so I've focused on making sure that we design a valve train that's both reliable, gives repeatability, gives the tuner an opportunity to tune the engine without having to tune around components. Sometimes with not a faulty component, but a weak component. It becomes a challenge for the tuner. So when I originally designed this product, the first and foremost in my mind was rigidity and repeatability. So in doing that, we made a reliable system that is consistent run to run and even race to race.
One of the things as an engine builder, when we're picking out camshafts or designing a camshaft for a motor, we go to great lengths to make sure that our lifts and durations and lobe separations are correct, the ramps and whatnot. And you can do all that, but if you have a valve train that is not correct, the valve doesn't follow what we told the camshaft to do. So you spend all this time coming up with this camshaft and you put it in the motor, but when it's in the motor, it doesn't do what you designed into it. So with a valve train that is more rigid, more lightweight, rigid at the same time, that will follow the camshaft and do what we ask it to do, we have a more predictable motor, tune-up wise, that we can go out and make other changes and know that the camshaft or the valve train is not the issue.
Yeah, if you would go a little deeper into that, Joe, because when we're talking about building engines, we're talking about doing things. Again, I know some people think that, hey, my magic is going to come from this part of the engine, or my magic's going to come from that part of the engine. But really, when it comes to making everything work together, and I think that's a big thing, making it work together. And like you said, making sure the valves do what the camshafts want it to do. Well, right in between there, we've got rods and arms and all of those other things. So why this is such a critical part of the engine?
It is actually the heartbeat of the motor. It has to, the intake valve needs to open when it's supposed to open. The exhaust valve needs to open and close when it's supposed to. And we design camshafts for that application. Blown alcohol, we're usually in the mid 800s to sometimes up to 900, 950 lift. We got duration at 50,000 lifter rise into the high 290s, into the low 300s. And now we have either a blower, a turbo, procharger. We got something blowing 40, 50, 60 pounds of air pressure on top of that. That all needs to happen at the right time. And we can't let it get mixed up. We can't have intake and exhaust valves open at the same time when they're not supposed to be. So you've got to be able to trust that valve train to do what we're asking it to do. push rod stiffness, rocker arm stiffness, rocker shaft rigidity. And he was talking earlier, Daryl was talking earlier, they're on a blown alcohol motor, they're called fatheads. And on a fuel motor, they're called a fuel head. And they're both still fit on a Chrysler Hemi block, but they're actually two totally different cylinder heads. And we try to make it to where that valve is controlled by the valve train and the push rod and the camshaft, not by other outside influences.
Yeah, that makes perfect sense. By the way, if you do have a question here, you can always type it into the chat, and we'll definitely get your questions to either Daryl or Joe. You know, Daryl, Joe was just talking about ratios and different things like that. So let's get into it maybe a little bit, maybe even a little more of the technical side about rocker ratios and all of that and where it's going.
Okay, we'll start with rocker ratio. The rocker ratio is fixed in the rocker. It's a physical part. The rocker itself, the ratio never changes. The changes that we do see are the dynamics of, we start with deck height. So on a standard, or we'll start with a short deck, and then a standard deck, and then a tall deck. Well, the resultant effect of pushrod angle based on those different heights, while it doesn't change the ratio of the rocker, it changes the ultimate lift at the valve. So it can be a misnomer, if you will, that we've had the question many times, hey, I'm using a 1.8 rocker, but I'm getting the equivalent of 1.7 of lift. And so what we have is we have a compound angle of the push rod, and I've done the math in my CAD system to derive what is really happening at the rocker arm versus what's happening at the cam. So if we have, for instance, a 500 lobe, the expectation is to have 500 at the adjuster, and that doesn't happen. So what I did was I laid it out in the CAD system to verify, the question was, where's my ratio going? Well, your ratio isn't going anywhere. The ratio is built into the rocker. That's a fixed value. But on the short deck, because of the increased angle, as the head comes closer to the lifter, what we see is about 465 of actual motion at the adjuster. So when we do the math, we might start out okay with a 1.8 on a 500 lobe. We should be, quote unquote, somewhere close to 900. I'm not sorry, not 900. And what we end up with is about 850. So, well, where's my lift going? It's not going anywhere. If you take that same rocker and put it on a tall deck, now we see about 485, 490 at the adjuster. So now there's not theoretically, there is more physical lift. But it's not because the rocker changed, it's because the angle of the pushrod changed. So with that common denominator, if you will, what happens with a tall deck, what happens with a short deck, there we see a difference in net lift at the valve. So how do we address that on this end? We address it, we can make a taller ratio rocker, or the engine builder can specify a taller cam based on their needs depending on the deck height of their motor. So we go into that. I hope that answers the question.
I think so. For someone who's looking at, obviously there are so many different variables of the different parts and pieces, like you're talking about taller and shorter. And I want to figure out, okay, what exactly do I need? I know a lot of people who are building engines are very savvy with what they're doing. But, if I'm running into something, okay, Daryl, what do you have? What exactly, here's what I'm trying to achieve. What do I need from you? How much can you help with that?
Well, on the intake rockers, we offer for the alcohol motors 3 different ratios: 1.7, 1.75, 1.8. And then I don't specifically tell the engine builder what lobe to use. They know what they're looking for as far as lift. So at that point, here's what we offer. We take a step back and let the engine builder make that decision.
Okay. We do have a question from the chat, and this could either be fielded by you, Daryl, or you, Joe. Does a higher ratio require less lifter and pushrod travel to achieve the same amount of lift as a lower ratio?
It would be the combination between the lobe and the, let me process this a little bit.
The rocker arm ratio, if as he said earlier, on a 500 load lift cam, a 1.7 ratio rocker, I think comes in at 800 lift, 825 lift, a 1.75 and a 1.8. So yes, you can, with a given height off the camshaft, increase rocker ratio to get more lift at the valve. That depends on the motor. All motors have limits. Back in the day, we were trying to get more lift out of the camshaft on a small block Chevrolet, and what we did is we found what they called a small base circle camshaft. But then that created another problem in the lifter following that camshaft because it was a small deal. So they ended up, an easier way would go back to the standard camshaft, but instead of a 1.5 ratio rocker, we would go to a 1.6 or a 1.65. And that's what Daryl was saying about, he builds the rocker arm 3 different sizes, 1.7, 1.75, and 1.8, and it's up to the engine builder and the camshaft to decide which is working the best. The higher the ratio of the rocker arm, obviously the more load that's going to be on that rocker arm. You can get up a 2-to-1 ratio rocker arm on, a different style motor. The load on that rocker arm goes up tremendously, correct, Daryl?
Exponentially. It goes up rapidly, and it goes up. We've actually seen the adjusters get blown off the rocker by making that change.
Wow.
So there it goes back to application. What are we doing with this? Some of the blown alcohol motors, pro mods that I run, I've tried shifting the car at 10,600 RPM, 10,700 RPM, and without a stable valve train and the correct rocker ratio, because we can get into, like you said, it'll blow the intake adjuster clean off of it because you're trying to move something that just really doesn't want to move. We have valve springs that we have 600 pounds of seat pressure and 1,400, 1,350, 1,400 at max lift. That's a lot of load on the end of that push rod and the end of that adjuster. So, I might back that down on the camshaft side of it and go with a 1.7 ratio instead of a 1.8 and put a little more in the camshaft because I'm going to run this thing at such a high RPM. Tractor pullers, a little bit different. You run 9,000, 9,200. And when you get over 9,000 RPM in any of these motors, the load goes up very quickly every time you add a couple of hundred RPM to a shift point or a finish line RPM through it.
Daryl, let's take this opportunity then to talk more about the whole. I know we've just really talked about rocker arms, but really the complete valve train and making sure that everything works in unison with each other.
Okay, based on what we've come up with, we start at the bottom of the valve train and bringing oil up through the stands into the shafts, through the rockers to the adjusters. So we have full-time oiling. Most of our customers will say that they have not burned a push rod since changing over to our assembly. Quite a testimony for, compared to what was happening prior to this valve train's inception. There was a concern at one time, but so we have full-time oiling to the adjusters, which prevents any damage to the push rods, at least in that context. Also, what we've done is we strengthened the area around the shafts. We also go through the shafts to hold them in place. So we're not only are we holding the shaft in place, we're compressing on the shaft in the area of the, I'll just use my example here. In this area here, we're compressing not only the shaft from the top, but we're compressing all the way down in the bottom here, because the screw goes through the shaft into the base of the stand. So that gives that added rigidity on both sides. Okay, and this is our single cylinder mock-up. This is not specifically for an engine. Typically, we will send this to a customer who has questions about push rod length. You can take this, put it on your engine, get your push rod length, and if you're waiting for your assembly, then get your push rods all ready to go. When we send you your assembly, everything's all ready, and it saves time. But also, you know, if you look at the stands, everything is radiused. There are very few sharp corners on this thing. In fact, in high stress areas, there's no sharp corners. So that helps distribute the load across the entire stand. When we first made it, we closed up the area in here to give it more strength between here, so the shafts aren't trying to separate. And then, of course, the shafts are 1/4-inch wall. Again, full-time oiling. The rockers, this particular setup has the springs on it. We make another feature that is, we call it a spring saver, where it's a solid clip that goes inside here, and it keeps the rocker at home. Sometimes in the spread lifter bore engines, the rockers want to bounce off the stands because of the straightened push rod. So we made the solid spacer that goes in here, keeps it at home, keeps primarily the intake from bouncing off the stand like that and hitting the plug tube. So that's another feature of our product. And like I said, full-time oiling through the rocker to the adjusters, keeps the cup and the push rod cool. And this particular set, we used to have the oil transfer right here. We've since eliminated that, and the oil transfer comes from another location on the assembly. We did find that there were a couple folks that had an issue with this area right here, and there was a cracking, so we changed the design. And like any product that we make, we practice continuous improvement. And if a customer comes back, and we want that customer to come back, we want them to come back and say, hey, here's an issue we found, can you address it? And we will address it right away. Whether it's one assembly or 10 assemblies, we will address it. And in this case, it was one assembly that somebody had an issue with. We addressed and changed the design right away. So we want to be reactive to, you know, what's happening out there. Other than that, everything is, you know, aircraft quality aluminum, chrome moly rockers, chrome moly shafts, and built for toughness. And like I said earlier, there are people that have this same assembly that have been in cars for 12 years and not a part has been replaced. Now, we do recommend checking the rollers periodically, you know, taking the assembly apart, cleaning it, and checking the bushings. We've had one bushing spin in 12 years and over 800 assemblies and another probably 3,000 rockers. We've had one spin, and that's because the system was dry. So it locked up on the shaft. But other than that, there's been no complaints at all.
Wow.
So, yeah, and there's and all of this has been laid out in CAD. So all of the components are built to match each other. There's none of this is by accident. Everything in here is purposed.
Forgive the layman question here, if you don't mind, Daryl. Like you talked about having, you know, a spacer in there instead of spring. Why, you know, springs versus the spacer? What's the difference?
With the standard 1/9 or 2-inch lifter bore spacing, the push rod is at an angle and it's pushing the rocker up against the stand. We're using the exhaust rocker as an example right now. On the intake, it would be the same thing. The push rod is coming up from the bottom. It's at an angle like this. When you go to the 2-inch or the 2.6 lifter bore, it's more straight up and down. So it creates a bit of a harmonic that starts bouncing off. And when it does, this area right in here comes in contact with the plug tube. And then of course it creates a dynamic that we actually fixed with the geometry of this setup. Instead of the rocker being offset on the valve side to side, now it's offsetting front to back. And so what it does is it ends up pulling the valve stem over and when it goes into lift. So by putting the spacer in there, it keeps the rocker arm at home up against the stand.
Okay. A couple of questions from the chat here. First of all, your thoughts, you were just mentioning bushings, your thoughts on needle bearings versus bushings for the rockers, any preference of where to use one versus the other? And Daryl or Joe, if either you want to field that.
I'll take the first part of that. The needle bearing is, in my opinion, the needle bearing is suited for high-speed rotation and long-running rotation. The rockers rotate approximately 35 degrees at max angle. So the contact area of the small pins in the needle bearing is very minimal. So the load on these rockers, and like Joe was saying, sometimes 1350, 1400 over the nose. We've seen 1600. All of that is being absorbed by a very small surface area with the needle bearing. Needle bearings have their application. In my experience, and not only in this industry, but in other industries, for the amount of stroke. So this thing is only covering an angle, maybe 30 degrees. So that rocker's doing this. Okay. So that is a very small area of that needle bearing. Now, again, those needles are going to be rolling. So you have constant new surface area, but the surface area contact on the shaft is very, very small. Whereas the bushing may cover 30%. Okay, so the bushing is carrying that load. The other thing is with the bushing, you have the opportunity for the oil to be in between the two surfaces and actually set up that hydrodynamic wedge with the oil to keep the two components apart from each other. Whereas in what I see in the needle bearing acts like a wiper because of the small surface contact will wipe the oil away. So the oil is good for flushing the heat out, but is offering very little in the way of lubrication. And the other part is when a needle bearing does fail, and it has happened, you end up with a severe amount of debris inside the engine, and then other problems occur. So we've had 0 issues with the bushings, numerous championships, track records, speed and ET. Again, reliability that we're looking for. That's what I see in the bushing versus the needle bearing.
That makes sense. Joe, did you want to weigh in on that? And any preference where one might be used over another?
No, everything has its places. And in that rocker arm, I think the bushing, it's a very thin wall bushing that they put in there. Just like you said, the load area of that bushing is way greater. When you think of a needle bearing, you're talking about a needle that might be 60, 80 thousandths in diameter. Well, when one side of it touches a rocker and the other side is touching the shaft, there's only maybe 3 to 5 thousandths of contact area, although it is against a couple of different needles as the needles are rotating through. But where that bushing is, I think on the exhaust rocker, what is it, about 2 inches across and 800 across the width of the rocker arm. So there's a lot of surface area. And with that surface area becomes strength. It holds, it doesn't let the rocker try to twist. And if you look at a Chrysler valve train, like he said, the push rods come up through at an angle. So it's pushing on one side of the rocker, on the up motion and on against the valve side, it's across the shaft, and so it's trying to twist. And that bushing, so it's actually rubbing on the top side also, and the top side is helping keep it aligned with that shaft. One of the things I wanted to talk about real quick was on the his rocker stands. And if you noticed the hold down bolts that go through the shaft from the top of the rocker, they go down through the shaft, and he actually bolts it in. It goes clear through the shaft and bolts into the bottom through that hole there. Been doing this for a long time, and one of the things we always had an issue with, we would break rocker stands. You'd be sailing down through there and a rocker stand, and it would blow the tops of them out, a little crack at the top. Well, he rotated those through bolts down from straight up and down, which at that point, that's where the stand is trying to go through the very top of the rocker stand, the shaft is, and he took and rotated it off, I don't know, 30 degrees, something like that, Daryl?
Parallel to the valve.
Parallel to the valve. So where the load is at now is not through the hole where he drilled to put the bolt in, it's over a solid piece, and that made the rocker stand that much stronger, which, like I said, we had a lot of issues with breaking rocker stands, and that seemed to have stopped the rocker stand breaking. I'm sure at some point, as we come up with more seat pressure and bigger diameter valves and things, he'll end up coming out with a stronger rocker stand to combat that.
Daryl, do you actually, I know you were holding it up a second ago. I don't know if, depending on who's talking, what people are actually seeing on the Zoom. So if you want to maybe, show us an example again while you describe it, that would be awesome.
As far as the load screw?
Yeah, what he was just talking about. And the parallel to the valves actually seems like just such a simple solution that makes sense as well.
Well, yeah, when I first was introduced to the valve train, that was one of the things that jumped out at me was, if we're going to load this thing, how do we want to load it? And when I look at if we were to go straight down, we're loading against. We're putting the screw in two different types of load. We're putting it into shear and tension, and so by rotating it over to the parallel with the valve, now I'm parallel with the energy. And I don't want to give up too many of my secrets, but the spring wants to push this direction and this direction. So my thought on that was, okay, so we're going to load the cap screw in shear, and then all of this is in tension. So it just a different way of looking at it. I spent some years in aerospace, so that it lended itself to doing that type of an arrangement. Plus it going through, we're not just holding the shaft in place. So previous versions just hold the shaft in place. And so the energy going through the entire assembly is kind of doing this. Because, one rocker's opening and closing, and this rocker's idle, the next rocker may be opening, and so on down the line. So the amount of stress that's being put into it is dynamic across the shaft. So by anchoring it, I wanted to restrict that and at the very least minimize it. It's still going to happen. There's a lot of energy in that valve train, and in everything that's happening, especially with 15 over the nose. There's a lot of energy, but the idea was to minimize it. Now, some of that energy being dissipated through a minor amount of deflection is probably a good thing. Because every time we make something strong, we find out that something else is weaker. So it's a trade-off. So, that's where I came up with that when I initially designed the system, and that's where we are today. And again, it's proven itself repeatedly.
Wow, that is pretty fascinating. I love just a great way to solve something. But to your point too, there's it's the cause and effect. There is an effect for a lot of things that change. Before we get into a couple more questions here, I do want to ask Daryl, compatible head manufacturers. for your valve train system. If we could get into that, so people know what you are compatible with, what they can be working with.
Okay, we have the what we call our FH2 is compatible with the Brad fatheads from 6 all the way to, I believe they're a TA1X now. They might be further, but all of our valve train, our FH2 valve train is compatible with the Brad heads. We have assemblies that are compatible with the AJPE stage 3 muscle head. Stage 4 muscle head, we went to a specific assembly designed for that head. The standard FH2 will also go on the Noonan Super and Super 600, I believe it is. And all of the Noonan 4.8 combinations. We make a special valve train for the Noonan 4.9 Hemi. We worked directly with them to design that valve train. Frankenstein, we made a special assembly for that head, and we've made special assemblies for Total Flow products and Webster heads for the 392s. We've done more than just the 426s. So we've covered quite a few bases. And then of course the latest and greatest, this is a 3D print, 3D printed mock-up for the 426 fuel head. And this is for the older models, the Brad 5, Allen 3 fuel head with the 2-hole stand. So it's just the hole here and the hole here. You can't see it. It's kind of hard to see with the black, but we'll look at it from the bottom. There we go. You can see it on the bottom there. There's 2 holes. So this assembly made its debut this weekend in Boise, as I referred to earlier. And this is all 3D printed. And so we 3D print new products to do a fit and function. So this is for the AJ3, Brad 5, and soon I will have for the AJ6 and other fuel heads for the big show stuff. I'm sure I'm leaving somebody out. Like I said, the Webster head and the Allen Johnson 392 417 fuel head. And let's see, who am I leaving out? I know I'm leaving somebody out, but we don't believe in a one size fits all, because there's, each head manufacturer wants to, they put the valves in different positions. And when somebody moves the tip of the valve at the top, we have to make a change. And in order to stay with the combination and stay with the geometry that we've arrived at and want to stay at. We have a minimum amount of sweep on the valve. Our recent valve trains have a minimal amount of sweep on the adjuster, which further reduces harmonics.
The detail is just amazing. Couple of questions from the chat here. And again, Daryl or Joe, whoever wants to take this. If you're changing rocker ratios, does it affect the duration of the shaft?
I'll defer to Joe on that.
Yes, when you change the ratio of the rocker arm, it does change the camshaft. Camshafts are designed for a basic rocker ratio. And when you change that rocker ratio, it's going to change the cam timing. Most of us engine builders, we put cams in now, and we go off of what's called intake lobe center line. So when you measure it, you're measuring from the center of the lobe down each side. The standard practice has been for years, 50 thousandths lift or rise, we would put the camshaft in at say 30 degrees. But on say a 116 lobe separation cam, and you've changed the rocker arm, well, that's going to move that intake's lobe center line. So if you degree it in off of intake lobe center line, then the camshaft will still act or be timed based off of that intake load center, and it will change the opening at 50 thousandths lifter rise, either add or subtract depending on what you're doing with the rocker arm. But if you go off intake load center line, that won't be a problem. That's a non-issue at that point. Just making sure that you know what you're doing as far as camshaft and ratio that you're going from. If you're going from a 1.75 ratio rocker to a 1.8 and cam, and if you've degreed your cam in off of cam center line, at 50 thousandths lifter rise, it may go from 30 to 31 or 32 degrees. But that's what you're gaining with this higher ratio rocker. You're gaining more lift, and you're going to gain a little bit of duration in the camshaft. And obviously vice versa. If you went from 1.75 down to a 1.70 cam center line, if you degree the cam in that way, that all stays the same. It just changes each end of the camshaft.
Okay, that makes sense. Daryl, is this a good opportunity to talk about, you and I were talking earlier about how just any little thing can change variables here, even thicker head gaskets and different things like that. Do you want to go into some of that detail?
Okay, what we were talking about there was initial setup and how we recommend people set up their push rod length on initial installation. And we recommend having the nut flush with the top of the adjuster with the nominal head gasket. So for instance, if your range, and this is probably extreme, but if your range is from a 50 thou head gasket to a 100 thou head gasket, you want to set up initially with a 75 head gasket, so that when you do have the variable of changing gaskets, then the amount of change at the adjuster is going to be minimal. So we don't want the adjuster to be too far away, up or down. It changes, if you get it too far up, it changes the way it oils. And it also pulls the oiling band up out of the rocker. And then with the adjuster, and I have one here, with the adjuster, the oil band, if you are too far up, you end up with that out of the rocker. And I'll use my intake rocker here as an example. So if you end up with the band outside of the rocker, the only thing that's left inside the rocker is a small amount of thread. So that's going to stretch that thread. Now, if you go to drive that adjuster back into the valve or rocker, now you literally have two sets of threads instead of one set of threads. So then it could be, misunderstood that, well, how, what's happening here? We have a faulty rocker. No, we don't have a faulty rocker. We've stretched the threads. So that becomes an issue. Also, what that does is that pulls that oil band outside of an area where it can actually oil through the rocker into the shaft. Actually, it comes the other way. It's coming through the shaft into the adjuster. So, in order to maintain that flush with the top of the nut, or close to it, that's why we say start at the nominal gasket thickness. We'll get this baby where it belongs. And there we're flush with the top of the nut.
Okay.
Okay, so that's, yeah, you can miss by a little bit on that, but like I say, we recommend starting with a nominal gasket thickness. On the alcohol motors, that may not be an issue. On the nitro motors, it's a huge issue, because sometimes you're running a 60, sometimes you're running a 120. So that addresses that. As far as the what we referred to as the differences between deck heights and how that affects lift, we covered that base already.
Okay. I'm going to jump ahead one question here, and we'll go back to the other one. It says, how does Reid define the ratio? Average ratio, ratio at max lift, something else?
Because I'm working with a physical part, I define ratio as the center line of the ball to the center line of the shaft, divided by the fulcrum length of the rocker. at the nominal position of flush with the top of the nut. So we have two-dimensional characteristics there. One divided by the other gives us the ratio of the rocker. And that's just a physical ratio. Again, things change in the motor because of pushrod angle. There could be deflection in the cam. There's other variables that would affect it. So the rocker has a physical ratio.
All right. Another question here. What is the current valve spring pressures being used?
My customers have told us that they're using anywhere from 450 on the seat to 600 on the seat. I did have a customer that was 650 on the seat. And depending on the spring rate, upwards of 1500 over the nose. I think Joe can sound on it.
And that is correct. Average is probably in that 550 to 600 range on the seat, like I said, on a blown alcohol motor. And depending on lift of the camshaft and total lift at the valve, 1450 to 1600, depending on the application. And one of the things that is a consumable on a race motor is valve springs. How many runs can you get out of a set of valve springs? And valve springs aren't cheap. And as Daryl had talked about earlier, gets into harmonics. Well, harmonics is one of the things that will kill a valve spring the quickest. Heat and cycling, and then the cycling is part of this harmonics. So if you can calm the harmonics down in that valve spring, it will last longer. We can go from maybe, I've personally seen 4 or 5 runs and a brand new set of springs are just completely dead, to 25 runs and they've lost maybe 10% of their seat pressure, which is an acceptable range. At that point, it's about ready to cycle out. That's a huge difference at $600 and $700 for a set of valve springs. And if the valve train can help control those harmonics, well, instead of 3 sets of springs in 20 or 25 runs, 1 set of springs, well, that's a significant savings.
Huge savings, for sure. We got another question from the chat. Says, when I quit 96, titanium springs were being used. Is that the same today?
I'll defer to Joe.
I don't think they're being used as much. We've changed over. And there's back and forth on triple springs and dual springs, because of the weight of the spring. You try to minimize some things. Spring rates. A lot of stuff has gone to a dual steel spring. Some people might use a triple on the intake and a dual on the exhaust, or a dual on the intake and a triple. It's I think it's what works for you. And I've gone through different manufacturers of retainers and keepers and valve springs, and it just seems like, but the titanium has not been like on the forefront lately. Back in the 90s and 2000s, we were using titaniums, and then they kind of got away from it. But spring technology has gotten better also, same as the valve train technology, mostly back to steel at this point.
Okay, thank you. Can rockers used to be control, or can rockers be used to control harmonics? Joe was just talking about the harmonics, and I don't know if this is better for Joe or better for Daryl question to answer.
Well, I think we could both chime in on this. Can rockers be used to control harmonics, where the harmonics come from? I think that's something that we haven't covered yet, that you and I talked about earlier, is rocker weight versus weight distribution within the rocker. And weight distribution in the rocker is more critical than the weight of the rocker itself. Because anytime we add valve weight by virtue of the rocker arm, then that's going to create a harmonic. It's going to want to loft, it's going to want to float. And so and of course, at the same time, as Joe referred to earlier, and I'll let Joe speak about that, but when you go from a lower ratio rocker to a higher ratio rocker and try to use the same cam, now you're accelerating that valve much faster than you were before. So that will create harmonics. So it may be a necessity to back off on the ratio to slow that rocker down or change the cam profile. So I think that's more along Joe's lines right there.
Yeah, well, I have used camshafts in the past that, talking about valve spring life, went from one camshaft to another, slight change, not a lot of change to them. And valve spring life went from 20 or 25 runs down to 5 or 6 runs. And it was just in the camshaft, but it's in the profile of the camshaft. The opening of the spring rate was too much for that particular spring. Not to say that I couldn't have put a different spring in it to maybe control that. That's one of the things in the race world is we're constantly looking for that right combination, and it's only going to be the right combination for today because as things rapidly change in that world, personally, I like the, I try to, as Daryl said earlier, it's the same with the head gasket. You use a nominal. I use the nominal rocker ratio of 1.75 and build my camshafts to match that. Every engine builder has their go-to camshaft, their go-to compression ratio, and that's where I'm at with my stuff now.
Okay. Daryl, yeah, I know we talk a lot about the rocker arms and everything, but what all does Reid Rocker Arms offer when it comes to the valve train and any other products you have out there?
We offer individual rockers. We offer the valve train assemblies. We offer also a sleeve installer, some pit tools, sleeve installer, a couple other small. Actually, one of them is quite large. We offer a belt tensioning device. A lot of folks use broomstick, axe handle, stolen piece of pipe from the neighbor's trailer, whatever they can to get that belt, the blower belt tight. And so when I was working on the high-speed motorsports car, I came up with a little not a contraption, a little like a cam that we put between the pulley, the idler pulley, and the stand, and just use a 11/16 wrench and pull on it. And actually a couple of times got a little too tight, but we had to find the happy spot there. So we make that. And, as a shop, we do quite a bit of work for other folks in motorsports. We make some blower components, blower plates, and adapter plates, blow off valves for the boats. We make all of Clifford 6=8. We make all of their manifolds, the post-cast machining. So we have 7 CNCs that stay busy all the time. And we're grateful for that. Very grateful.
In looking at what you were showing us also, I mean, there's obviously a lot of thought, a lot of ingenuity, everything that goes into the design of the products that you put together. If I'm interested in maybe trying to find a new or a better way to do something, is that something you could help me with as far as consulting and design services?
Yes. I have designed specifically for individuals. I cannot and will not say who they are, but we've done some special projects over the last year with some things going on. Unfortunately, admittedly, was a challenge to get some things done. But in the past, like I said, we worked. The one that I can say that we worked with is we worked with Noonan and building the valve train for their 4.9 assembly, and that's worked out very well. So I've been working with CAD systems for, gosh, that means I'm old, close to 30 years. And I've been a Mastercam user for that same amount of time. And I do all my design work on the CAD system. And basically what I do is I search for that the assembly. I build the assembly in the CAD system. That way I know everything goes together. I know how it goes together. I can see oil passages and interferences or create interferences for press fits and things of that nature. So I have 3 3D printers that when we do come up with a concept, we can 3D print a mock-up or a sample part rather than going through all the machining processes. Saves time and gives us the opportunity to fit check parts prior to turning them into metal. So pretty much a well-rounded supply of knowledge and capabilities within the shop. I have 3 very good people out on the floor, soon to be 4, and a wonderful office manager, and we're just here doing it.
That's awesome. By the way, I've discovered as more gray grows on my chin. It's not old, it's experienced, and that sounds so much better. But
There's a reason this is shaved.
For you, Joe Bettencourt Motorsports, obviously you're teamed up and using some great products as well. But tell us a little bit about your business and the racers that you serve.
I mostly the Pro Mod, West Coast Pro Mod is where my services go to. I just spent the past month in Las Vegas with Street Outlaws, fastest in America. I have a customer that runs a car out there. I just ran this past weekend with a fuel car for the Nostalgia. So most of my stuff is blown alcohol. I like the Pro Mods. I like anything blown alcohol. Boats. I've got a couple of boats out there that I run. And I try to steer my customers. Obviously, it's always about price and whatnot, but I like Daryl's valve train. I like his knowledge. I've had some very in-depth conversations with him about valve train because I've had some issues and I want them fixed. And I go to the people that I think can help me fix those issues. And me and Daryl are actually currently working on one right now, and we're continuing to gather some more information to see if we can, come to find what the culprit is.
Well, gentlemen, this has been just fascinating. I mean, it really has. It's great learning new things and also learning better ways of doing things, and would recommend anybody, check out Reid Rocker Arms through EPARTRADE, have your engine builder, go through there, whatever it might be. But Daryl, Joe, really appreciate you being a part of today's Race Industry Now webinar, and looking forward to continued success for both of you.
Thank you. And thank you, Daryl, for inviting me on.
Thanks for having us. This is an exciting time.
Absolutely, and absolutely, Brad, you're correct. What a fascinating webinar, and we have about 100 of those already recorded on the EPARTRADE platform. So, Joe, if you haven't actually on valves, we did something really good recently with Feria and I think SuperTech, and so we have I think in library about 100 of those, very technical. But
and we're approaching 10,000 attendees.
Correct.
And it's just growing.
Yeah, right. We started to count last week when we were with Jeff Hammond. We said we started to count how many people we have registered over those webinars, and we're approaching 10,000. So this is really good. This
amazing.
We did something right, and thank you so much, Daryl, for sharing your expertise. I mean, this is fascinating. So this webinar has been recorded. It will be available later on this afternoon on the EPARTRADE platform. We'll share the link with all of you. It will be also on YouTube, on our YouTube channel. So thank you very much for joining us today. We will be back next Wednesday, and we're going to have the people from Pagid Racing coming back to do part 2 of their tech webinar on racing brakes. So again, thank you very much for being with us today. Please go on EPARTRADE. You'll see some of Daryl's product right now on the homepage. You can connect with him directly there, and then we'll see you again next week. Thank you very much.
Just for the record,
everyone.
Yes.
Just for the record, if I may, there's the result.
Nice Wallies.
Nice view.
Grateful to have them.
Absolutely, absolutely. Excellent. But congratulations and thank you very much for being with us today.
All right. Thank you for having us.
Okay.
Thank you.
Bye-bye.
See you guys later.